All right, good day, grade 10 science students. Today what we're learning about is how to name ionic compounds. We're going to learn how to do formulas. We're going to start by doing just ions, okay? So what are ions again? This is review. We're going to look at a couple periodic tables where we look at the different ions and Lewis structures. And then we're going to just talk about ionic compounds in general. And what we're doing is something called nomenclature, which means nome means to name, okay? So we're learning nomenclature of both names and formula. For example, a name of sodium chloride is sodium chloride. The formula for sodium chloride we're going to learn is NaCl. And this is a special type of compound known as an ionic compound because it's made up of, anybody want to guess? Ions. It's made up of ions. So that's what we're doing right now. So here we go. Yeah, so what are ions? What exactly are ions? Ions are an atom that have a charge, okay? And they actually come in two flavors. We didn't quite mention it. Flavors or types, okay? So the first type is something known as a cation. And we're going to learn that metals form cations that are positive because they have more protons. That means that they lost electrons. If you lose electrons, you have more protons and therefore you're positive. And then we have anions, which are actually going to be the nonmetals, you'll see in a moment, and they actually gain electrons. They have more electrons than protons. Remember, protons are positive, electrons are negative. If you gain electrons, you're negative, you're an anion. If you lose electrons, you're positive, you are a cation. So let's talk about what atoms on the periodic table form cations or anions. Okay, so let's look at this right here. This is our periodic table again. There's a line right here that goes down, and it's most of these blue guys here, right where I'm showing you with my cursor here. Everybody on the right-hand side, this is the nonmetal. So all these guys right here. Everybody on the left side, all these guys, these are my metals. And we're going to find out when we look at the Bohr-Rutherford, something interesting happens. Now this might upset you a little bit, but I got rid of everybody in the middle. So this is the same line that I was showing you. So let me take a look here. So this is actually the line right here. And you can see that I got rid of most of the metals. And here, so this is the actual line right in here. On the right hand side, these are all the Bohr-Rutherfords of the nonmetals. And over here, these are all the Bohr-Rutherfords of the metals. So nonmetals on this side right here, metals over here. And we look at the Bohr-Rutherfords. They don't have neutrons in them. They should have neutrons here. But if you look, how many valence electrons are in this group? Look, they have different amounts of shells. But you can see that they all have one valence electron. This is group 2. They all have 2. This is 3, 4, 5, 6, 7, 8. So it shows you how many valence electrons they have. Let's look at one more periodic table. This last periodic table looks a little bit more familiar to us, but what it's done is it's not showing Bohr-Rutherfords anymore. It's actually showing the Lewis dot diagram. This is 1. It has 1 valence electron, 2 valence electrons, 3 valence electrons, and so on. So these all the way over to the nonmetals. Here's the nonmetals in yellow again. And they actually have, depending on what group they're in, it tells you how many valence electrons they have. Now, why does that matter? Well, those valence electrons will determine the chemical reactivity of that substance. So fluorine, chlorine, bromine, and iodine, they all have 7 valence electrons. Are these fluorine, chlorine, and bromine, and iodine, are they stable? No, they're actually neutral right now. What are they going to do to become stable? Everybody that has 7, are they going to lose 7 valence electrons, or are they going to gain 1? Well, the answer is that they're going to gain 1. Because they all have 7, everybody in group 7 is going to gain 1 to get to 8. So everybody is going to gain 1 electron. Everybody's going to have a negative 1 charge. So the moral of the story is that if we look at, so we know we got negative 1. I'm not going to tell you the moral yet. So if you got negative 1 on 7, if we look over at 1, you can see that everybody has 1 valence electron. So underneath of those, they have a full shell. So what's it going to do? Is it going to gain 7 to get to 8, or is it going to lose 1? Well, the answer is it's going to lose 1. So if you lose an electron, that means you have more protons. Everybody here has a positive 1 charge. So every group will tell you how many valence electrons it will have, but it will also tell you the charge that it will form as an ion. Okay, now here we have another interesting periodic table because this is showing you the charges that it form for each group. If you're in group 1, and actually you have a positive 1 charge, just like we said, because they all have valence 1 electrons. Well, in group 2 you have 2 valence electrons, and that means you're going to lose 2, so everybody here has 2 valence electrons, they get a 2 plus charge. Now I don't want you to worry about these guys, these are the transition metals, but let's go over to the nonmetals here. Look at these nonmetals actually are all forming a 3 plus, and then we go over to 5. And when you have 5, that means you actually gain electrons and you get a negative charge, they're negative 3. So in summary, you can look at the group to tell how many valence electrons you have, and you know that if you gain electrons you become an anion. So nonmetals become anions because they're all gaining electrons to get to an octet. And the metals, they'll all become positive. Look at all these positive charges because they all have less than 4 valence electrons. They lose to become an ion. So we learned that metals form cations, and we learned that nonmetals form anions. That means they like each other because if they form ions, they become stable, they get full shells, but they have positives and negative charges. Positive cations will like anions, negative anions, and so together they form something called an ionic compound. Here's an example of lithium from group 1 and fluorine from group 7, and they end up liking each other because they have opposite charges. Okay, so an ionic compound is formed between a positive ion and a negative ion. Positive ions are metals, they're on the left side of the periodic table, and negative ions are nonmetals, they're on the right side of the periodic table. So if we want to write formulas, we have a simple thing here. I'm going to take a metal, calcium, and I'm going to take iodine, a nonmetal. Okay, and we know that they're going to form ions, and when they form ions to get a full shell, we know calcium has a charge of 2. Okay, and we know iodide, which is in group 7, has a charge of negative 1. Okay, so we just have to remember what those charges are on each one. And if we cross the charges, that means that you're going to end up getting CaI2. So that means you got 1 calcium with a 2 plus charge, and it likes to hang around with 2 iodides because overall it's negative. So what we do is we write Ca1I2, so 1 calcium for every 2 iodides, and we just write CaI2. We write it in the lowest terms, which we'll talk about what that means. To give a name, all you do is you write the name of the first element, and you write the same name of the second element, but you put iod on it. So calcium is the first element, and iodine is the second element, and I'm just going to change the second name to iod. And that's it. That's how you name compounds. So that's the end of the video. I got 1 minute. I'm going to just give you one more example, and that will be it. Okay, so I want to give a formula for this. So what I'm going to do is I'm going to look up on the periodic table, and I'm going to find that sodium is in group 1. And because sodium is in group 1, I know that sodium, the formula is Na for it from the periodic table, has a positive 1 charge because it's in group 1, and everybody in group 1 has a positive 1 charge. Oxygen is in group 6. That means it's going to gain 2 electrons, and if it gains 2 electrons to get to 8, it has a 2 negative charge. So I look at the periodic table again, and I have Na2O. To find the formula, all I do is I bring down the numbers, and it's going to be Na2O, just like that. And that means that I have 2 sodiums and 1 oxygen, but we don't show that oxygen. So I have a sodium ion, 2 of them, oh man, and oxygen, 2 negative. So let me just clean that up. So that's clean there. So we have 2 sodiums and 1 O2 negative. So 1 plus 1 is 2 plus and 2 negative. So the point is that the positive charge equals the negative charge. You need 2 sodium 1 pluses to match up with 1 O2 negative. And sodium oxide's formula is Na2O. They always want to be neutral. Next we have an example here. We have Ca3P2. So how am I going to name this? Well, I look at this and I notice that it is a metal. So I look on the periodic table on the left hand side and I look for it. And I just give it its name once I find it. And this is calcium. And then we look at the nonmetal, which is on the right side of the periodic table. My eyes are going to the right now. and I look for its name and it's phosphorus, but I'm going to change the ending to phosphide. So what you got to do is you got to get rid of the us part and you put IDE on there and it's calcium phosphide. That's it, folks.